Hey friends, welcome back. So the content for this video was actually recorded some time ago, and I had to put the project on hold because I was really busy with something else, unfortunately, so I couldn't get to it for a while. Most of this video is just the assembly of the cassette tape interface, but if you want to watch the operation of it, the testing and operation, skip to about minute 35 or so, and I'll show you how it works. And thank you for watching, and I hope you enjoy. Hello, welcome back. In the previous video of this series, where we're assembling the SCELBI reproduction, we made the SCELBI TTY interface board and also put it into an enclosure and hooked it up to a Teletype. I had an old Teletype laying around. It was a what is it called, a DS3100 or something like that. I had two of them, one with a screen and one without a screen. And we were able to verify that the TTY interface was actually working, but we had to use two separate DS3100s because one was the receiving end and the other was the transmitting end, because the DS3100 only has one TTL loop and it can work either way. So we had to use both of them to kind of have a fully functioning TTY interface. We also tested the serial interface that we assembled for the SCELBI computer and hooked it up to the terminal and verified that to be working. After that, I've been really busy with some personal stuff. I just didn't really have time to get back to the SCELBI computer. But I also spent some time on, let me just show you right here, on this device right here. This is a DS2000. It's another Hall terminal slash Teletype. So the one that we were using in the previous video is a Hall DS3100. This is a Hall DS2000. I received this one in a broken state. Basically, if you powered it on, it just didn't power it on. Turns out that the power supply unit was actually broken. I had to, some of the capacitors were blown and had to be replaced. But when I did that, I turned it back on and the screen actually showed some data, but it was just random data. Sometimes it would just scroll on the screen and just like all over the place. So it wasn't very steady, and the data was just all like garbage data. So I spent some time on this Teletype here trying to fix it. And the reason why is because this specific one actually has two loops, one input and one output, so transmit and receive. This is the video port right here. So I was thinking, okay, I can actually use this as a terminal for the, well, I guess the Teletype for the SCELBI computer, since it has two loops. So I spent some time trying to fix it. Had to replace a couple of ICs, and also the memory chips were bad on this thing, so I had to replace that. Eventually, I got it working, and I hooked it up, and I just couldn't get it to work. And turns out that even though this thing has two loops, it cannot receive and send at the same time. So when you're typing a command in, it's sending that ASCII character signal to the SCELBI computer, and the SCELBI computer is responding back, like echoing back that character, and basically we're not receiving that character back because you can't send and receive at the same time, and it's pretty much happening at the same time. So unfortunately, the time I spent trying to fix it just didn't really pay out that much, since I couldn't really use it for the SCELBI computer. But this thing is fixed. Maybe we'll use it for something else. These are really made for like ham radios and things like that back in the day. So yeah, I guess what I'm gonna do for now, until I get an actual Teletype that has both receive and transmit, a full duplex one, I'll just use the terminal, the serial port of the Hall 3100, and use the serial board for that, for communication. But in this video, we'll be assembling the audio cassette interface. We have two boards. One is the audio output to write data out of the computer, and audio input for reading data into the computer. And we have the schematics right over here. These are really hard to read on this sheet of paper that I printed off of the SCELBI.com website. If you want to see the schematics, you can check out the website SCELBI.com/documentation. This is a tape read schematic, and also we have the tape write over here. There's also, so the website doesn't actually contain the parse layout, but Mike Willigall, who also assembled the SCELBI computer reproduction at one point, he constructed a document that contains the parse layout. So actually, I think he posted it on his blog, but I'll probably link to it in on the GitHub page for this cassette interface, so you can actually reference that. But here on page 128, 129, we have the audio tape read card image and also the parse layout, and also 124 and 125. This is the audio tape output card. Again, we have the parse layout. So we'll be using these two pieces of paper for the parse layout. We'll also be using this enclosure here, and if you remember, we used the same enclosure for the TTY interface. This is the Butt Industries CU3009-A. It's I think a 3-inch tall by 6 by, I believe, either 8 or 9 inches. And we'll be able to fit these boards in here just fine like this. It'll be a pretty good fit. It will have some Amphenol connectors here, and also the power plugs. One of the two of the Amphenol connectors will be used for the input and output from the computer and to the computer, the I/O ports, and the other Amphenol connector will be used for the actual plugs that will be used to plug into some sort of audio device to read and write data to. And that's pretty much it. We have quite a bit of components here. We'll be using this right here. This is the hole punch. This is like a really old one. This is actually, so the funny thing is, this is actually the specific one that I think that was called for in the construction manual, if I'm not mistaken, for the SCELBI computer. The specific one, but you can find a modern one. There are modern hole punches that you can use for punching holes in the enclosure here, but I just thought, might as well use this since it was mentioned in the construction manual. So we'll be using this to punch the 3 holes for the Amphenol connectors, which by the way I don't have on here. They're actually off screen a little bit. And we'll drill the holes for the power connectors as well. And of course we have a couple of random components here, the standard setup here, a bunch of resistors, capacitors, and ICs, some transistors. And we also have a couple of these strange looking capacitors that were on the original boards. This is a 0.1 microfarads capacitor, and there's just other values here as well that we'll be using. I think these are electrolytic capacitors, if I'm not mistaken, but they're low values. And yeah, that's pretty much it. And the way I'm thinking of assembling is basically I'm gonna assemble both boards at the same time, since we'll be using both of them. So for example, I'll install the resistors on this board, and then I'll install the resistors on this board, and just kind of install them in parallel. I think we can go ahead and get started. So let's go ahead and start with the resistors, and we'll do this audio output board first. So let's go ahead and get started on that. I'm going to use my handy dandy tools here. So I got my little pliers I'm going to use for bending the resistors, and these trimmers we'll use to trim the leads, the access leads. So let's go ahead and reference these documents here. We're doing the audio output, so I will use this parse layout sheet right over here. And let's see, yeah, there's a couple of resistors, so I'm just going to place it over here and go ahead and speed this up for you, just so you don't have to wait for me. Alright, so I got the resistors installed except for one right here. I think that's the R16. And here it says 2700. I don't know if I have a 2700 laying around. I'm going to double check that to make sure that that's actually the right value. And if it is, I'm going to have to find one somewhere. But yeah, I think we're pretty much done with the resistors. So I did just verify that it is in fact 2.7 kilo ohm here, based on the schematic and also the images from the original board. I actually don't have a 2.7K, but I think we can actually combine two resistors in parallel or in series. In my case, I'm doing it in parallel to get a value that's close to that. So I'm going to use a 6.8 and 4.7, so 6.8K and 4.7K ohm resistors in parallel like this, and we'll get about 2.7K. So let me go ahead and solder them in. Okay, that should do it. So we got two of them in parallel, basically stacked on top of each other like this. That should be about 2.7, 2.8K, but of course this is a 5% tolerance, so it might be, it might be off anyway, so it doesn't really matter too much. I don't think this 2.7K is high tolerance. Let me just double check really fast. So the original image actually shows a I think a silver stripe, if I'm not mistaken. I think that's 5%. Alright, so those are the resistors. We should be good there. Let's do the diodes and the Zener diodes. So I was going to say these diodes right over there. I'm going to do the Zener diodes first. And we have 5 or 6.2 volt. Here it's calling for 6.3. I'm going to use 6.2. It's not much of a difference. And so this is the audio tape read board, which is this one right over here, and it goes right over here, so it's really pretty tight in there. I'm curious if it's gonna fit. Yeah, I think it should fit through these holes. Yep, perfect. So we'll insert this in here. We also have a couple of these 1N4148 resistors. Let me just, sorry, not resistor, diodes. Let me just go ahead and raise this up a little bit. Let's go ahead and install all the diodes on this board. And these are tiny. Look at that. These are pretty small. But we want to make sure that we orient them correctly. Based on this layout here, the stripe on the first top two goes to the right, and the bottom two go to the left. So we'll gotta make sure that we orient them correctly. All right, I think that's all the diodes on this board. I do have one more of these 1N4148. I wonder if it goes on the other board. I don't know why I have it there, but let's check the other board. I know it has the Zener diode, so we're gonna install that for sure. So let's take a look at this. I think it should fit the same way as the other one, and the band goes to the left, or the stripe. Okay, so that's the 6.3/6.2. In my case, 6.2. I don't see where else we have diodes on this board, so I guess we'll just skip that one. I probably just got an extra one by accident. If anything, we can always install it later. Yeah, and that should be it for the diodes, unless we missed one. I think I'll do the IC sockets. We have a couple of capacitors, but I think these are pretty, well, some of them are smaller, but most of them are pretty large profile, so I'll hold off on that. And also transistors, and we'll hold off on that as well. So yeah, we'll install these IC sockets, and I believe they're mostly just 14 pin. Yeah, I don't know if we have any. No, no, I think there are a couple of 16 pin if I'm not mistaken, but most of them are 14 pin. So let me go ahead and do this smaller one first. I just realized something. This right here is actually a relay, as we can see on this layout sheet, but we can go ahead and install a socket in there, because the relay, actually let me show you what the relay looks like. It looks something like this, so it should go into a regular socket. So let's go ahead and install a socket in that place as well. And I think I just found the extra diode that we had missing. It actually goes right over here, so I'll install it in a little bit. And there we have it. We got the IC sockets, and I also installed this diode here. What should we do next? I'll do these the fuse holders and the fuse. All right, I'm gonna do the transistors next, and we have a couple of 2N2222 and 2N3907, if I'm not mistaken. I see a 222. Oh man, that thing's hot. 2N222 and yeah, 2907. Yeah, let's see, how do we orient that? I guess we oriented the way it's the footprint is laid out. So in my case, this little tab is facing northwest from my orientation. I think something like this. I'm gonna put something underneath just to kind of create a little bit of clearance between it. I will also go ahead and install this LED here. I think this is the activity LED. So basically, when there's some activity being outputted, or I guess being inputted into the this board, it's gonna blink. So the shorter lead, I think, is the minus side, so we'll orient it in such a way that it's pointing down. I give it quite a bit of clearance just to kind of, I don't know, it's just a small LED. I wanted to lift it up a little bit. All right, we also have this variable resistor. I think it's actually installed in one of these in this specific card, if I'm not mistaken. I think it goes nope, it's actually on this one. Oh, okay, I remember. So this specific one, I installed a 10K resistor here, but it's actually supposed to be this variable one. So I'm gonna unsolder it right now and remove it and install a variable one in its place. There we have it. I think this resistor will be used to kind of like tune the reading of this card, basically the sensitivity. All right, I don't need this 10K resistor. I guess we can install the capacitors next. That's pretty much it in regards to solderable components. So let's go ahead and install those. And that looks good. Let me actually take a look at this. Yeah, so the output card right here has this bigger, what is it, 0.47 microfarad capacitor. And I think this is the same one that the original uses. I wanted to go with the same one just for authenticity. But it goes right over here. And let's see, what actually goes over here? Okay, so that looks like a little, So here it actually calls for 0.33, but the original actually has 0.47. I guess it doesn't really matter, but I think I'm gonna go with the original capacitance. And we have a couple of footprints here, so it's a little bit confusing. I think the pin actually goes right beside this resistor here, and these other ones, I believe those are just yeah, so that makes sense. These other smaller ones are just VS. So this one will go right over here, and the band, the minus side, will face up. We'll insert it into this topmost pin, or sorry, footprint, and also the bottom side will connect to this 10K resistor. Okay, so I just inserted these ceramic capacitors, got a couple of 0.1s and one 0.02. And I think I missed one capacitor here, one electrolytic, 10 microfarads, so it goes right over here. Yeah, so the original actually has a jumper between this pad right here and this pad. So I might actually do that, but I'll probably look into why we actually have this one as well. And we'll see. I guess it'll be an option. If something's not working, we can modify it. We can change the jumper. What else do we have here? We have a pad here for a capacitor, and that capacitor, I'm not sure why it's there. Let me see if the original doesn't even have anything here. Interesting. Maybe the schematic has it on there, but once they started assembling this board, they probably realized that, hey, maybe we don't actually need this capacitor here, and they didn't install it. So I'm probably going to leave it off as well. I will install this jumper here right now, and then I'll move on to the other board with the capacitors. Yeah, so like I mentioned, there is a capacitor here. I think so. It says C4 right over here. Let me actually take a look at the schematic and see what that capacitor is for. So we're looking at the right board, and that one connects to. Let's see, let's see how we can find it easier. So I think this trace right here is ground. So it connects to ground and what is a Z? Ground and Z, AZ. Yes, so it's this capacitor right over here. And yeah, I think this capacitor is actually not supposed to be here. It makes sense not to actually include it. So yeah, we're gonna leave it off. But yeah, it's in the schematic for some reason. I actually read somewhere that these schematics, these boards specifically, were outsourced to another engineer. So Nat Wordsworth and his partner, they designed pretty much all the other boards for the SCELBI computer, except for these boards here, which were actually designed by supposedly an audio expert, somebody that knew what they were doing with these audio cards. So maybe they just made a mistake with the C4, who knows. But I'm gonna leave it off. Alright, so let's go on to this board. This one has a couple of more capacitors here that we will need to install. Alright, so I went ahead and installed these ceramic capacitors, and the reason why is because I wanted to see where we had any leftover footprints for this capacitor here. This is a 0.047, and I realized it actually goes right here, and it's just kind of hard to see it on the parts layout here. But let me go ahead and install that. Okay, the one thing that I'm not 100% sure yet about is these are these capacitors, the 0.1 capacitors, microfarad, 0.1 microfarad capacitors here. I'm not sure if they have. I'm not sure if they're polarized here, if they're electrolytic or what. So I'm gonna have to test them and see what they're showing. If anything, I'm gonna have to resolder them and reorient them. But I think I'm gonna leave it for now just the way it is, and I believe the last thing that's left to do is to install the ICs. So let's go ahead and remove all these metal plates off these sockets and install the ICs. Alright, I went ahead and installed the remaining ICs on this PCB here. We have this relay right over here, and only a couple of pins are actually being used here. The center 6 pins are not being utilized. Just an FYI. Yeah, and I think we're ready for testing the board out. So we got 2 of these boards. We got the output card right here and the input card right over here. Yeah, we're ready. I guess the next thing we want to do is make this case over here, drill the holes and punch the holes out, install the brackets and whatever the socket, whatever it's called, the edge connector, and install these PCBs into it so we could actually test it. So I will actually go off screen and do that. And I'm also going to make some wires that will connect to the SCELBI computer, the I/O port, and also the wires that will connect to some audio device like a tape recorder or something like that, or a computer, modern computer that is, just so we could actually load data into the SCELBI computer and also save data, save our work from SCELBI into some sort of audio device. Okay, so I'm going to go ahead and get started on that, and I'll be back. And here we have it. I got the connectors added here already. So we got 2. So P1, P2 are actually I/O connections for the computer. And S1 will be going to an audio device. Got positive 5 volts and ground here. I also added some lettering from the Electroset lettering as I did with the TTY interface. And got some of these rubber feet on the bottom so we can actually set it down and it'll be nice and even. Additionally, let me just take this out. I actually went ahead and wired it up inside as well. So we got 2 of these edge connectors here. These are 22 pins each. So the top and the bottom of the inside of it, each pin of these, the top and bottom of each pin is actually connected together into one single pin. And I wired them up to these Amphenol connectors here, which I'm going to share the list of where each one goes on the GitHub repo for the SCELBI build, just so you can reference that. And additionally, I made these cables here. So we got 2 just straight through cables that basically connect from the SCELBI computer I/O ports to these 2 Amphenol connectors here. It's just 11 pins straight through, just like I did with the TTY interface. So there's 2 of these, and these are about 3 feet long. So let me just show you how long they are. There you go. It's about 3 feet long. And also made another one right here, and this side is the male side of it, so it'll plug into this S1 connector here. And on the other end of it, it's also about 3 feet, and this one's actually a little bit longer. The other side of it is like this. So we got 3 connections here. One is for writing data, so if you want to save data onto a tape drive or save data onto a tape, this will go into the mic input of the audio device. The other one is a read, so I labeled them. So I got W for write, R for read, so we're going to be reading data from some audio device, so we plug in this into the headphone jack. And the third one is, I label it as REM, this is for the remote. So we don't necessarily need to use this, but some older, I guess, audio devices had a remote input, so you can actually control like the tape motor, so you can start and stop it. And the SCELBI interface has something like that. It's actually controlled by this relay right over here. So whenever there's data being written to tape, it will start the tape, and when it's done, it will stop the tape. Yeah, so I got this, you know, so each one actually has, so there's 12 conductors here, and I combined a couple of them just to kind of use them all up. There is one thing that I wanted to mention. So the remote is fine, and let's take a look at the schematic. Actually, I have it right over here. So this is the this schematic right here is the tape write. So we got the S15 and S17 of the connector here. Those are both going to the remote right over here, and as you can see, it's actually being controlled by that relay. So I used 2 conductors for each of these S1 and S15 and S17. So 4 wires going in here, 2 conductors for each. Pretty simple. And then we have S12, and if you actually notice something right over here, there's S12. That'll be the positive side, but there's no negative side. So negatives, it's not showing any negative being connected to anything. On the tape read, we got S11 and S11. We got a positive and a negative right over here. So the tape read is just pretty basic. We got the conductors for that, but for the tape write, we got only the positive side, but there's no ground. Basically, we need to connect a ground to the tape write output. So I got this write over here, and as you can see, I got a red, white, and a black. The red and white is the S12 output over here. They're just connected together, and the black is actually ground, and it's the same. So we already have a ground coming out from S111 right over here. As you can see, it's connected. The S111 is connected to ground here. So I just used that conductor, the S111 wire, and since I had 2 conductors, I sent one to the right and sent the other one to the read. So there's a black going here and a black going here, and they're all connected. They're both connected together on this other end, and it's actually S111, which is ground. Just an FYI. So let me set those wires aside. I also set these schematics aside, and let's see if I can actually insert the PCBs into the edge connectors here. So let's see, which one do we... So I think the write actually goes on the bottom, at least in my case. So the read's on top, write on the bottom. And yeah, so this PCB right over here, this will be the SCELBI write output, or write or output card. It'll be inserted on the bottom. So let's try to put it in. I haven't done it yet. Okay, so it's in. That's one thing I forgot to mention also, but as you can see here on this side of the board, as you can see, it's basically touching the bottom of the enclosure, which is metallic. So we're gonna have some shorts there. We're gonna have to do something here to keep it off the metal, kind of like keep it level. Additionally, like if we try to put this read board in, and let's go ahead and do that. I just want to see what it's gonna look like. It'll probably touch the board on the bottom. And so it's touching the bottom, and we could potentially have shorts here too. Well, I guess in this case maybe not, because it's just touching the capacitor. It might be fine, but what I'm thinking of doing is adding some sort of spacers here. One that will create some clearance between the enclosure bottom here, and also some clearance between these 2 boards, and kind of like this. And I haven't come up with the solution just yet, but I'm thinking I'm going to use one of these brackets that I used in the TTY interface as well, which, by the way, all these parts I'm going to include it on the list on the GitHub repository for the SCELBI build. But I'll probably use one of these brackets on both sides of these and just add something there to kind of create some spacing, but I need to come up with a solution still. I think for now, while I test it, what I'll do is I'll just put some temporary spacing right over here with this little foam that was being used for the ICs, and do some testing and then add the spacers a little bit later. So let me go ahead and move everything over to the SCELBI setup that I have on my left side here. I actually moved everything to one side just to kind of have it all in one place, and see if we can actually hook this up and start testing it. Alright, so I got this set up right here. As you can see, we have the SCELBI 8B computer right over here, and I also have the ASR DS3100 terminal that I'm using as a serial interface right now. And on the left side, we have the power supply, and on top of that is the SCELBI TTY/serial interface, which I'm connecting the ASR terminal to. And on top of that is the audio tape interface that we just completed or assembled. On top of the terminal, we have the cassette tape recorder. I guess it's a player and a recorder. And we got the jacks connected to them. All right, so I just tried to turn it on and give it a shot, and I wasn't able to actually get it to work. And it turns out that I forgot to wire up the sync signal to pin 10 of the ports that are connected to the audio tape interface, which is output port 3 and output port 3 and input port 3, which are actually the fourth ports from the right side if you're looking from this side, because it starts with 0, so output port 0 and 1, 2, and 3. So output port 3 and input port 3 need to have pin 10, both of those, connected to the sync signal, which is XA02 row of the backplane of the SCELBI computer, B side, so it'll be on this side of the backplane, and pin A or B. A and B are connected together, so either one should be okay. So I went ahead and connected the sync signal to the input and output ports for the tape interface ports, and tried it again, and it still didn't work. And again, I did this off camera just to kind of try it out first before we go and try to troubleshoot it. And it still wasn't working, and I was trying to figure out what was going on, and it took me a while. I did a lot of troubleshooting, debugging. I used my oscilloscope for that, and in fact, as you can see right here, I actually did a lot of doodling and trying to debug it. So basically, I was trying to check different ICs and different pins of each IC and see what the signal was doing. Basically, what I was getting is just a single blip on the output. In fact, I could actually hear it when I was recording it. It's just a single blip. And I was trying to figure it out, and turns out that there's actually a bug, and the bug is actually on the schematic. So if we look at the, I got the schematics right over here. Let me just set these aside. And if we look at the schematic for the audio write interface, it's kind of hard to see here, but just you can look it up if you look at SCELBI.com/documentation website. But right here, the Z1 IC has pin 7 connected to P19, and pin 7 is also connected to pin 13 and also connected to Z2 pins. And this is supposed to be the enable pin, so it basically enables these two ICs to transfer bits from one side to the other, basically. And it has pin 7 connected here, and that's actually the wrong pin. So I think the schematic is incorrect. I think it should be pin 6. And I just looked at the PCB, and I had pin 7 connected to pin 13, which is how the schematic has it here. But if we look at the actual PCB, pin 13 is actually connected to pin 6 right over here. So the enable pin is pin 6. I went ahead and modified the PCB, and I cut the trace between pin 13 and pin 7 of Z1, and connected pin 13 to pin 6. So that, I think that should fix the problem. And just if anybody purchased this PCB from me, let me know in the comments, or maybe send me an email, and I can send you an updated PCB, or I guess a fixed PCB whenever I can get a chance, if I can actually get them ordered from China. The tariffs are kind of high right now, and things are a little bit more expensive, but I'll try to get them fabricated and shipped out as soon as I can. But I think the quickest way is to just go ahead and fix it. Cut the trace between pin 13 of Z1 and pin 7 of Z1, and just connect pin 13 to pin 6 with a little piece of wire. That should do it. Also, since we're looking at the schematic here, this capacitor right over here, the 0.02 microfarads capacitor right beside the 330 ohm resistor, Mike Willigo mentioned that he actually had some issues with that capacitor, and the timing was basically off. So he actually updated that one to 0.004 microfarads, which solved his problem. I actually went ahead and did the same thing. I don't even know if I had the timing issue or not, but I just went ahead and updated that to 0.004. So if you're having issues with timing or something's not working, take a look at that. It might be the culprit. Okay, so let's go ahead and try it again. And as I mentioned before, I have been trying just off camera. So let me go ahead and power on the terminal right over here. And actually the power button broke off, so I have to use a screwdriver. So that's turned on. And let me go ahead and power on the SCELBI computer as well. Okay, so the SCELBI is running, the terminal is running. And you might have noticed, but the SCELBI computer is much quieter than it used to be. I actually went ahead and modified the power supply and changed the fan to be a little bit quieter. It's still pretty powerful, but it's just much quieter. So much nicer as well. Alright, so on this terminal, I'm going to go ahead and press FN transmit. I'm just going to enable transmitting. And on the SCELBI computer, I'm going to go ahead and jump to the monitor program at what is it, 06000 in octal. So let's just go ahead and do that and press run. I think I messed up on that. Okay, there we go, and we got that prompt. I'm actually going to go ahead and press Control D, and what that does is basically it reinitializes the prompt from the beginning. And the reason why is because we might have some garbage data that came through while we turned the computer on. So now what we can do is press K and then Control L, and what that does is basically initializes the text buffer. So what we're going to do is we're going to write some text into the text buffer and try to write it to a tape right over here on top of the terminal. So I'm going to say press A and then Control L to start appending text, and I'm just going to do something very simple. I'm going to say hello from SCELBI, period. Okay, and then I'll press Control D to basically say to save it. Okay, and then we can actually press L and then Control L, and what it's going to do is print out a text buffer for us. And as you can see, there's actually a little mistake here. Let's try it again. Yeah, so I think there was a mistake when it wrote it, so there's something going on with the serial interface. But that's okay. We're not testing that part of it yet. So what we want to do now is write this to tape, and the way to do that is to press W. Well, let me just reset that because it looks like we have some garbage, but we're going to press W, and then we'll press Control L, and it's going to write, and it basically goes back to the prompt. I don't know if you heard that, but there's a little click, and that's actually the relay turning off. So basically it's stopping the tape. If you remember, we have that remote plug, that jack, that is used to stop the tape, and it's basically being driven by the relay. So let me take a look at this tape here. I'm gonna actually bring it down a little bit just so we can see what's going on here. I'm gonna rewind the tape. Okay, so it's not actually working right now. Nothing is working because of this remote. So let me... Okay, I'm gonna rewind, stop, and I'm gonna press record, and then I'm gonna pause it for a little bit right over here. The reason why I just want to get to the actual tape, I'm gonna put the remote pin back, jack back in, and now it should work. See, the problem with the remote is that it doesn't let you rewind or do anything if this is plugged in. It's basically turned off. So now it's recording, but of course it's not spinning yet because the relay is off. So if we press W and then Control L, let me see if I can do that with my one hand. And it did not work. So this remote did not turn on. I wonder if I can... Oh, it's because I paused it. Yeah, let's try it again. I'm going to press Control L. Okay, now it's spinning. Yeah, there you go. When it finished, the tape stopped, and we're done. And actually, what I'm going to do is I'm going to unplug the microphone and also the headphone. Actually, go ahead and unplug everything. Stop the tape, and we'll actually play the sound that it made from the right. It's going to play right now. There we go. And that was it. So it has a short, steady tone in the beginning, and then it has the actual data being written. So I think the right board seems to be working. I don't know if it's correct or not, but it's doing something. So what I want to do now is I'm going to plug in this headphone jack, and I'm going to rewind this. I will read data into the buffer, and we'll actually, let me see if I can put this here like that. I'm gonna pause it first, press play, and I'm gonna actually clear the buffer first. So I'm gonna press K and then L, and if we do L and then Control L, we get an I, which means that you know, the buffer is not initialized. There's no text in it. But we're going to try to write data from our tape that we just recorded into here. And the way to do that, for the text buffer at least, is to press E and then Control L. And it's going to sit there waiting for some data. So we're going to unpause the tape and let it run. And there you go. It finished running. It returned us back to the prompt. And we heard the relay click again, so basically we know that it's done. And in fact, the remote would have stopped the tape, but I have it disconnected right now. But let's go ahead and press L and then Control L. Sorry, L and then Control L to see what it read. Yeah, hello from SCELBI. So it looks like it's working properly. So actually, I did this off screen, but I had to adjust the read variable resistor, the 10K potentiometer. It's a 10K, and I had to adjust it to about 5 or 6K to actually get the read to work properly. And in my case, the volume is almost at the bottom, so it's barely on. So in your case, it might be a little bit different. So just play around with the volume and with that resistor to get it working. So far, I've had it working pretty consistently, so I'm pretty happy with that. I actually had it connected to a Windows XP laptop from 2004 or so that I have had laying around, and I recorded data onto that and read back data into the SCELBI computer, and it worked pretty well as well. So this is it for the cassette interface, or the audio tape interface video. So far we've only been able to read and write into the text buffer, but we can also do the same when we do the assembler, which we'll probably do in another video. It uses slightly different commands for that. In the next video or two, we'll be building something else for the SCELBI computer. I think it'll be probably the keyboard, which, if you remember, we didn't actually, well, at least I don't have a set, the SCELBI oscilloscope PCB set, but the keyboard would actually be used with this oscilloscope set. I don't actually have it in my collection or set, and I actually have something else in mind that I want to do instead of the oscilloscope, and we'll actually be using the keyboard for that. So stay tuned for that. If you haven't subscribed yet, please do subscribe, and thank you for watching. Bye-bye.